All right, thank you. Super excited to be here. I've never been to one of the Atlassian User Groups here in Europe, so very honored that you're having me here. I did come from very far away, Amsterdam this morning, which wasn't too far. It's a short train ride, but I am based in California with Atlassian in San Francisco, and you're having just incredible weather right now, so it's really nice to be here.
For you.
Yes. So something we've been asked to talk a lot about from our other user groups is this idea of DevOps. There's a lot of confusion in the market around DevOps and what it is and whether you're doing it right or wrong and how other teams are doing it. And the thing that we've heard most often from people is just show us some specific examples of how people are doing DevOps. And so what we're going to try to do is I took a 90-minute presentation and I've shortened it up quite a bit. But if you want to get deeper on any one of these 10 areas, I'll be able to share the link with the user group. And rules I think is maybe the wrong word. There are really no rules in DevOps. It's more of a philosophy and a guidance to help your teams think end to end, more of a solution-oriented way as opposed to very, very specific ways of working. But we always do have to answer the question, what is DevOps, when you start a session like this? And the way that we talk about it at the basic level is that Atlassian and our tools help build the culture and collaboration layer for DevOps. And what we mean by that is really connecting the development teams with the operation teams, with the support teams in a way that allows them to work together faster and with less risk. And often those things seem to be at odds, that you could go faster and also reduce risk. But that's one of the things that a lot of our DevOps customers are finding, that they can ship more often with less risk and they can recover faster in the event of an incident. So how many folks have heard this quote before? The software is eating a world quote. It's pretty popular. It's been going on for a long time. Mark Andreessen said it, I think, in a Wall Street Journal article. But it really is an incredible transformation that we're all going through. When products were made out of physical goods, most often, it might take a year to change the assembly line, to change the product, to change the factory. And so those changes might take a year or more to reach your customers or to reach the retailers. And what's happening now is that software is actually changing the speed at which all of those physical objects that we buy, whether they're cars or shoes or tablets, the software is actually where a lot of the value is coming today. And so we see this in even some of the most unusual companies that we don't think or wouldn't think are software companies. And two examples I think that are really interesting to talk about. One is Dominos Pizza. Now, we laugh at Dominos Pizza sometimes because it's not the best pizza. But what Domino's has done historically is they have figured out how to distribute their pizza really, really well. And so it's no surprise that Domino's Pizza is investing again in distributing their pizza. But they're investing in software to do it. They're investing in apps for online ordering where you can track your pizza all the way through the process. And so even with average pizza, Domino's is distinguishing themselves in the market in a way that we may not have thought of 10 years ago. They've had a 240% increase in their IT workforce in the last, I think, 2 years. The other one that's interesting is General Motors hiring 8,000 software developers. And that is a perfect example of something that was a physical object made on an assembly line that is now being differentiated a lot by software. An interesting stat, so all of Facebook is about 60 million lines of code. There are connected cars that have over 100 million lines of code in them now. And it's not uncommon, well, for me, I'd like a car that might go fast, it might handle well, it might sound nice. A coworker I work with went and bought a Volkswagen because it had the Apple Car Kit. That's the only thing he cared about when he talked to the dealer. Will it play my music? Does the Bluetooth sound good? And can I afford it? That's what he cared about. And so you're starting to see this more and more where the decisions are made over something that the software developers can improve daily or weekly if they'd like to. And there's actually some data that supports the teams that have undertaken these DevOps practices are actually the highest performing teams. And there's all sorts of surveys, I think, that go around in areas like this. But these are pretty big numbers. So teams that report DevOps practices are releasing 30 times more frequently. They're seeing 60% fewer failures. And then with those fewer failures, they're seeing faster recoveries. They're twice as likely to exceed their goals in profitability, market cap, market share. And to really understand how strongly the folks that did this research believe in it, they consult with, they've consulted with hundreds of companies at least around DevOps and Agile practices. And they've actually built an investment model based on how mature your IT and your software team's practices are. And then they look at that model as a way to inform investments that they make. And they've been able to outperform the market based on IT and software development team performance. So they've not just done the research, they've actually tested it out and really seen those results in the market. This was a number that surprised me a little bit when we asked our customers. We said, how many folks are doing some form of DevOps practices or have been doing it at their company? And we got back almost 2/3, which was a much higher number than I expected. I'd be curious, just from a show of hands, is DevOps something that, or are any teams here doing any DevOps practices? I think it all probably depends as we go through the presentation as well, what counts. Because I think a lot of DevOps is actually things that high-performing software teams are already doing. Teams that have figured out and understood Agile. Teams that are using Scrum or Kanban as ways to organize their work. And so we'll get into these 10 rules of Atlassian DevOps. Now, not every team at Atlassian follows every rule. And not every team is organized the same. But these are a set of principles that if I were to change teams inside of Atlassian, I would understand these. And it would be easy for me to adapt to the way that team works. So the first one's probably a difficult translation. But the first rule of Atlassian DevOps is to eat your own dog food. And it's a slang term. The origin of the term is actually a little mysterious. So eat your own dog food basically means that you test and use the products you build in-house. And so at Atlassian, we run on beta versions of everything that we sell. We test it on ourselves. We frustrate ourselves at times by putting out a very early release internally. But that is us eating our own dog food. And the origin of this, allegedly, is from one or two different things. One is an actor who used to boast that the dog food was good enough for his dog, so it should be good enough for your dog. But the more popular explanation of this is that the president of a dog food company was said to actually eat a can of his own dog food at their annual shareholders meeting to show how good it was. Don't go that far, it's not worth it. But if anybody asks you where that came from, that's the best we know. So what I've done is, as we built this out, I've broken out the 8 stages of DevOps within Atlassian and the way that we build, plan, run, deploy, and operate a product within the company, and then how that process connects together across all the teams. So the first stage that we want to look at is the plan stage. And I'm sure many of you are familiar with Confluence, where we'll assemble customer feedback into user stories, into product requirements documents, and we'll break those user stories down with one click from Confluence into Jira, and we'll create a set of tickets. And the developers are able to take one of those tickets and begin building inside of Bitbucket with integration between Jira and Bitbucket. And as we move forward, we start to see the teams use tools like Bamboo and Bitbucket pipelines for continuous integration and continuous delivery. The next stage is the deployment stage, where again we see the teams deploying the software using Bamboo or Bitbucket pipelines, and then we get into operating. And so this is one of the key differences in a DevOps practice. The operation is very much connected to the team that planned it and built it and deployed it. And so it's actually a cycle. And we'll talk a little bit more around how operating really informs what gets planned and what gets built next. And so you actually start to see this connect. As we decide to build a product and release it and test it and get feedback, it informs what we do again. And it can inform that at a very, very small level, a single feature or a canary deploy, which we'll talk about later, or it can totally change the course of a release. And the way that that communication continues on every stage of this process is that every team is using HipChat at some point in this operation to share information between teams or to connect information from various stages in the cycle. An example that we'll talk about later would be monitoring. We do a lot of monitoring within our products so that we understand how they're being used. If you've shipped a feature, you want to know if customers are adopting it, and so that information will be captured and shared with the team. Now, typically in this process, the participants are going to be a product manager or a product marketing manager, helping with the design and the requirements. They'll typically be working with a designer to wireframe and scope out the ideas, and they'll be working with developers to build the solutions that they've articulated. That developer will participate typically with a QA engineer, or that developer will apply QA practices of their own, and ultimately we'll have an SRE as well, a site reliability engineer. And so this team that we often call a triad, even though it's much bigger than 3, are typically the participants in the DevOps process. Now, sometimes a single team will be responsible for all aspects of development, pipeline, testing, and even managing the server desk, the service desk, doing the user communications and handling the documentation. So one single team will have a responsibility for every aspect of their product, or in some cases it might be a microservice. So for example, within our cloud products, we have a common media microservice. And so that microservice makes commitments to the Jira team, the Confluence team, the HipChat team, that their product will meet a certain set of needs. And if it's not meeting those needs, we know that we can go right back to that team and say the performance is lagging, or we need a different type of file support. Now, the other way that you'll see this often is within companies, it will be teams collaborating. And so these teams will also function as a bit of an end-to-end product delivery team. So if we dig into the planning stage, there's a question that often comes up in user groups. It comes up usually when you're talking with Atlassian fans and customers, and that is, should I use Scrum? Should I use Kanban? We can have some beers afterwards and debate this out. It'll be fun. But one thing that is pretty common, and I'll actually I'll go into this a little bit in case anybody's not familiar. But very quickly, Scrum, you identify a set of work in a specific time frame, and your goal is to complete all of that work by the end of the sprint. 1 week or 2 weeks. And that's a very focused process, right? The development team is focused on developing. On the flip side, Kanban has a different approach. So Kanban's approach focuses on cycle time. So instead of trying to complete the sprint in 2 weeks, Kanban-focused teams try to minimize the cycle time from when a feature or an issue moves from the left-hand side to the right-hand side. And so Scrum originated in Japan for product development, and Kanban originated in Japan as well, but it was focused on the automotive sector and manufacturing. And I think one of the key differences between a team that is just focused on agile practices and a team focused on DevOps is traditionally a change over to a Kanban style of working. And the reason they do this often is, we'll just jump to the slide, because of unplanned work. So you've heard the statement, I'm sure, that no great plan survives contact with the enemy, right? As soon as you have a great plan, something happens. And if you've ever worked on a product that's a service, right, that's always up, you know that something happens in production, something happens in the market, and something happens where you have to stop what you're doing and start fixing it, or start servicing it. And so this is a common way of working for IT teams. They're used to working off of a queue. They're used to solving problems in real time, but for a lot of development teams, this is a disruption. And so the disruption looks a lot like this. You've spent a lot of time building out your sprints. You've identified the work on the left and the time on the right. And if things are going well, you're completing your work on pace to pass the sprint. And when you pass the sprint, your development team is happy. They've achieved their goal. They've built what they said they want to build. But what happens in a DevOps org, what happens in a world where your product is a service, is that those best laid plans for your Scrum meet something in the middle, and it changes. And so your development team is now frustrated, and you're not able to complete the work that you had planned to complete in the sprint. And this can be a very frustrating process if it happens over and over and over again. And so what we generally see are these teams having friction. This is usually one of the stages before a DevOps transformation, where the development team is busy developing, the ops team or IT team is busy making sure it doesn't go down and resolving incidents, but they don't work as closely together. And part of it's because of the Scrum versus Kanban. Part of it is just different teams within the company. So what we're trying to do really is to break down that wall and help teams as they move through to continuous delivery start to work together. Because as you get into continuous delivery, you need that collaboration with IT to go quite a bit faster. So the second rule of Atlassian DevOps, it's all about flow. It's all about that process of work and moving it across the Kanban board to reduce cycle time. And so what we've seen teams do is they've taken Scrum and Kanban and combined them into a beautiful looking ice cream cone called Scrumban. And has anybody heard or seen this term before? Yeah, a few folks for sure. We had a lot of customers telling us that this was happening, and they wanted a way to work more closely with the IT and ops team. And they wanted a way to use a Kanban board, but still to be able to prioritize it like a Scrum board. And so what we've built is something we call KanPlan. And KanPlan takes your standard Kanban board with your to-do, in progress, done column as an example. And what it starts to do is it helps you manage this endless backlog, which is one of the things that's hard to manage on a Kanban board. And the way we do it is we go into settings, and we allow you to take a set of issues and drag them onto your Kanban backlog, or KanPlan. And so what this now does, when you go back to your board, we'll have this little feature flag here, but once you click that, you'll actually be able to organize your Kanban board and prioritize the issues and groom the backlog like you would typically do in Scrum. And so it allows you to manage both planned work as well as unplanned work. And the last thing that it does that's sort of nice is it allows you to take it off of your screen. Right? When you're not dealing with the full backlog, you can't see it. And so it makes your board much cleaner and much easier to organize. And for those on Jira Server, it's coming soon. So if you watch that ticket, it will be there. It's live in Jira Cloud right now. So the next stage that I wanted to take you through is the build stage. And the third rule of Atlassian DevOps. One source of truth. Especially as your teams get larger, it's important to have a single source of truth to figure out what's going on with your build, your test, what's going on with your team. And so the issue page inside of Jira is that page. And you can see links in here to show you your branches, your commits, the status of your pull request, and even the status of your build. This is important partly on the build side, but it actually becomes important as well during incident management and having a way to tie code to changes and to people. So you can connect a Jira ticket to the code that the developer has built, and if you're going through and trying to resolve an incident, it can be helpful to have that mapping. And so in this case, developers don't like to spend all of their time in Jira, so the Atlassian developer will click Create Branch. It'll take a look, and it'll copy the branch name right in from the issue. It will also show you the status of the master, so your build is green. We're good to go. Which takes you to a rule that's pretty consistent within Atlassian. The next rule, the fourth rule, branch for everything. So we hold pretty strong to that within the company. We want to keep the master green. That's one of the prime rules within the teams. Keep the master always in a releasable state so that you can release it at any time, and isolate the feature branches so the developer can work independently and then test their builds before they go live. So one of the other benefits of continuous delivery is this idea of frequent releases. So how often do you do your taxes every year in Germany? Is it once a year? And is it sometimes difficult? It takes a lot of time. You have to relearn it every year. At least for me, it's a pain. And same with US taxes. Every April, I have to remember how to do it. Because it's not something I do frequently, number one. And number two, you're doing it all at once. And so there's a lot more room for you to make a mistake. And so what we see internal teams doing is releasing as frequently as possible. And the strategy here is, by releasing frequently, you get good at it. You get good at your builds, at testing your builds, at deploying them, at doing merge checks. But you also have a smaller bit of code that you would have to work through in the event of an incident. So you can address an incident faster because it's a smaller amount of work that you have to look at. And lastly, this is a core Agile practice, but it's so frustrating for a development team to have good product that isn't in the hands of customers. And so smaller releases that you can release more often accelerate that process. And so you can kind of see this as we build it out. We use branches for every change at Atlassian. Instead of committing right to the master, everything is done on an independent branch. Once the code is tested and all the tests are passed, it gets merged back into the master. So a branch gets tested, merged into the master, merged into the master. Only merge commits that have gone through a test and have been reviewed. And that makes sure that the master is always releasable and always has stable code. Now there's a capability that we often hear about in DevOps, and it takes many forms. But one is this idea of automation. There are a lot of things that we can automate to help keep our team size down, to help us become more efficient. And this is a very basic version of automatic issue transition. It only has 4 states. But what you can do here is actually bind your Bitbucket branch workflow directly to a Jira ticket. And so what you can see here is that when your branch is created, that button that we clicked in Jira, the issue transitions to in progress. And this seems like a very simple transition. But oftentimes, developers don't want to spend their whole day updating tickets in Jira. Or if they do, they might have so many to update, they make a mistake. And so, to the extent that you can automate this process for your team, you should have higher quality, you should have better tracking. Your product team will know what's going on with a piece of code or a feature. And so in this case, it's automatically transitioning when the pull request was created. The pull request has been reviewed and merged, and now it's automatically moved into the done state. Now, that was a simple workflow. I'm sure you're all familiar with the level of detail you can go into for Jira workflows. But you can imagine building this type of workflow for a number of practices that you have to do on a regular basis. And finding those places between your development team and your IT or your ops team that these workflows can be automated is helpful. And workflow triggers are one of the ways that you can make that happen. So a quick look at some of the triggers that are available here. But there's often the term two-pizza team that you hear companies talking about. Amazon made that term famous. And it's the idea that you keep your team small enough to be fed by 2 pizzas. Because a smaller team has less collaborative overhead, fewer meetings, less material to read. And so small automations like this can take some of that day-to-day work off of your team. And so we tested that idea. We thought, all right, so if teams are using these things, is it actually doing anything? And so we surveyed a set of customers that use Jira and another source code system, and Jira and Bitbucket. We found 14% more frequent releases, 23% more issues. And I think some of that just comes down to the simplicity of a workflow with triggers versus some of the manual work that folks are doing otherwise. So the next stage is continuous integration. So on the continuous integration side, we use continuous integration to continually make sure that our code is working correctly. We've all heard that saying, it worked on my machine, I don't know why it doesn't work in production now. And so we want to use continuous integration to make sure it's still working. And when we get a green build, we can move it back into the master with another rule that comes on top. Build every push. So building every push is another way to make sure it's actually going to work as planned. And so what you'll see here, Bitbucket pipelines will continuously monitor your code, monitor your builds, and you'll actually start to see that feedback showing up within Bitbucket. So in the same UI that you have your source code, you'll be able to see the status of your builds. And I'll show you what that looks like in just a minute. We have 2 products in this area that help with continuous integration. One is Bitbucket Pipelines, and that's going to be the cloud version. The second one is Bamboo, and that's going to be the server version, which I'm sure you're all very familiar with already. So what I wanted to do, because it's newer, is just to show you a little bit of what Bitbucket Pipelines looks like. And so if you haven't used Bitbucket in a while, you may actually have seen this new feature here. This is how you get pipelines started. It's built right into the source code management tool. And what it allows you to do as a developer is it allows you to see and manage your builds right in the same place that you manage your source code. So in this case, we can see the status of builds right within Bitbucket. A Bitbucket pull request looks like. You can see the author here, Cameron. Cameron selected 3 people to review. And when those reviewers come in, what they're going to do, they can go ahead and approve it here. But before they do that, they may want to check out the status of the builds, or they may actually have some questions. And so what they'll do is they'll navigate down, they'll look at the diffs in the code here, and then make an inline comment. And that inline comment is part of our human-driven review. In this case, what does this line of code do? Once it's approved, the author has the ability to merge it back with the master. And this is a way, again, for us to have fast feedback within the company. So very quickly, when you submit for code review, your peers can ask you questions, make recommendations, and we can then test that build and deploy it back to the master. Basically, what we're after here is that Cycle time on the development side is largely linked to the skills of your developers. There's not a lot on the process side that we can do to improve that. But the place where a lot of DevOps organizations look to drive significant improvement is here. That period of time from code complete to ready to ship. And that's an area where better collaboration between the dev, the ops, and the IT teams can actually make a difference in how fast you get product out to customers. Another way that we actually accelerate this internally is with a bot and HipChat. So what we do is we update a room for the team, in this case the build engineering room, and we identify where they're waiting for approvals, as well as the status of builds, and things that are ready to be merged. And so this kind of openness is really helpful for the team, so they can help out if we're falling behind. But it's also a core element of DevOps. You hear people talk about transparency quite a bit. And that transparency makes it easier to know what's going on, to see what changes have been made, or to resolve an incident. So the next place that we're going to look here is on the deploy front. And the 8th rule of Atlassian DevOps, which is to automate everything you can. Anything that you do frequently, over and over again, that could be subject to common human error or oversight, we try to automate that. Automated testing is one of the first steps that we undertake. But really, this is about reducing human error. If there's something that can be turned into a workflow, we try to do it. And it comes back to this. There's strength in a small team for a software team. That 5 to 8 to 10 person team seems to function much better than a larger team. And it's a trend that we've seen playing out over the last 30 years. With waterfall moving to agile teams, and we had this evolution of small agile teams. And we're seeing that continue with DevOps. We're seeing it continue with microservices, where companies are taking pods of staff, engineers, product managers, and putting them together in a small group. So there's also a saying that tests are awesome, but production is truth. And this can be scary at times when you think, are we going to test in production? That seems risky. But it's actually something that we do, and we don't do it to piss you off. We do it because there is nothing like production to actually test if it's working the way you want. Now, we don't just ship out, we try not to just ship out a feature to everybody and have you beta test it for us. We actually try to do this in a focused manner. And so we do that with a tool called Launch Darkly. And what Launch Darkly allows us to do is feature flagging, or what some folks will call canary deploy. And so with Launch Darkly, we can deploy a feature to a very small portion of the user base in production. And that will actually give us an idea of how it will perform as we start to bring the load up on it. And so an example here, we moved from Amazon ECS to Kubernetes, and we wanted to test how that would function in production. But we couldn't turn it on for everybody. So what Launch Darkly enabled us to do was to whitelist a set of user IDs. And once we whitelist those, we could pick a fixed percentage of users that we wanted to roll it out to. So in this case, we might say, roll this out to 10% of this whitelist. And what that lets us do is it lets us see how this is going to perform in the wild. And if we gain confidence in our infrastructure, we can increase the rollout to larger and larger numbers. But if we get feedback that performance is degraded or support tickets are coming in, we'll turn it back and change the feature. Now, the second place that we see the team testing things in production is around experimentation. There are times when you may go into a product and you may see a different feature of a new feature that we're testing. And this is a way for us to settle arguments between product managers. There are many ways to solve a problem with a feature, and it's difficult to know which one is correct. And so we can use Launch Darkly and feature flagging to set out a control group and send out a variation, and then see how it performs. We may look at things like time to engagement, people completing a task, people building a pipeline as an example, to see how it's working. So operate. Operate is probably the last rule of Atlassian DevOps that I'll cover tonight. But it's the idea that shipping is just the beginning. So how many of us have ever been to a launch party? I've been to several of them. We don't do launch parties anymore. Not like we used to. Not like when I worked in shrink wrap software, right? Shrink wrap software, it was, the thing is done, the salespeople will go and sell it now, let's have a party. And the transition as you move from building products to services, the transition from going from a more traditional model to a DevOps model is the idea that shipping is actually the start. That shipping the product is now when it meets the customer. It's when it meets production. It's when you'll know if it's working. And so we don't see teams setting goals internally with, we must ship this feature by this date. Their goals tend to focus on, if we build this feature, will it have a certain level of adoption? Will people use it? And so shipping is the beginning. It's probably actually the exciting time for a lot of the developers because now they can actually see it in the wild. We can see the data around how it's being adopted and how it's being used. So with that, feature launches used to sort of look like this with a lot of beer, probably a headache the next day, but really now our teams will release and they turn on the data at that point. And so there are still launch parties, but they tend to happen at events like this with good partners buying us the beer as opposed to the day that we ship the code. And so that's a big transition that I think we've seen play out within the company. There's a much, much deeper version of this deck that I can make available to you that we just recorded. But I hope that gives you at least 10 small looks into ways we're building and running software inside of Atlassian.